So what we're going to be doing today for discrete math, it's something that, again, it's very visual, it's something you've never done before, it's a graph that you're going to be creating, but it's something that's very good to be able to help resolve things that we need to figure out in terms of grouping, right? What we're going to be working with today is something called resolving conflict. Resolving conflict using color. Using color. Right? And again, sometimes people are trying to figure out, what does that mean, resolve conflict? Sometimes resolving conflict means that you're trying to come to a solution based on the information we're given, right? And so, like, for example, one prototypical problem that we have when it comes to resolving conflict is trying to figure out different ways that we can group items, right? We know that certain things can't be grouped together with other things. Almost imagine if you're going out with 5 friends. Some friends get along, other friends don't. This girl doesn't like this girl, this guy doesn't like that guy. So if you needed to go somewhere and you guys are all in the same group but people don't like each other, you gotta figure out what cars are going in and how many cars are gonna go in, right? Just so that there are no issues and no fights. That's what this means. When we're looking at resolving conflict, we're trying to figure out basically how many cars we would need or how many containers we would need to be able to keep things together. So basically, if you want to look at that situation where people don't like each other, how many cars, what's the least number of cars you would need to get a bunch of people to one place without there being any fights? Resolving conflict, getting rid of conflict, getting rid of issues, right? And so when we're looking at resolving conflict, we literally do this by using color. And I'm going to show you what I mean by that, because we actually color to be able to figure out how many containers, the least number of containers we would need, right? But whenever it comes to this, there's typically a table, which I'm going to give you. And so this table is going to represent the information that we have, right? And so this table here, and I'll explain. Let's make this A. Right? Let's make this B. Sorry. Let's make this one B. Right? Make this C. Make this D. And make the last one E. And again, it shouldn't mean anything to you yet, but it will. Because the first thing I'm giving you a table that's going to show you all the ones that can't be grouped together, right? Almost think, if these were people, these would be the names of people. So like A would stand for Ashley, B would stand for Barry, C would stand for Claudia. Again, these are just names. Imagine that these would be the people that don't like each other, right? These are all the things that cannot be grouped together. This is how we want to look at this table, right? And from there now, we're actually going to want to put down everything that we cannot have together. So like, for example, we know that A can't be with C, can't be with D, and it can't be with E, right? So A, we're going to know, it can't be with C, can't be with D, can't be with E, right? B can't be with D, and it can't be with E. C can't be with A. D can't be with A and B. And then E, same thing, can't be with A, can't be with E. So again, if you want to read it this way, it's A can't be with C, A can't be with D, A can't be with E. B can't be with D, A can't be with E. C can't be with A, D can't be with A, D can't be with B, E can't be with A, and E can't be with B. So all the red X's show us literally all the ones that cannot be together. It's all the ones that cannot be together, right? Because given that table, again, table shows us one thing, just gives us information all gathered neatly. But what we want to do is we want to create a visual so it's easy for us to see how many containers we would need and basically what the differences are going to be, right? So the best way that we can do this is by creating a graph using vertices and using edges, right? And so the first way that we actually create that is by getting 5 vertices, right? Getting a vertex for every single variable that we have, right? So we need 5. We need one for A, we need one for B, Actually, this is dumb, and I'll show you why. We'll get to that. I want to leave open circles, right? And the reason, again, we want open circles is we're going to use coloring, which I'll get to. So we have A, we have B, we'll put C here, we'll put D here, and we'll put E here. And again, order doesn't matter. Doesn't literally matter. This could have been D, this could have been E, this could have been C, that could have been A. It doesn't matter. We just need right now 5 vertices to represent those, right? So we have A, B, C, D, E, so we need A, B, C, D, E. If we only had 3 A, B, C, we would only put 3 A, B, C, right? And now, the next thing that we're gonna do is we're gonna go through this table to actually see the ones that we need to connect, right? So basically, just because we're connecting them doesn't mean we're putting them together, and I'll show you that then later. So with A, we're gonna draw now segments for all the ones that are marked off, right? So A, we're gonna draw with C, so we have A goes with C, AD, AE, right? So AC, draw a line, right? AD, draw a line, draw a segment, I'm sorry. AE, draw a segment. And all I'm doing is I'm just connecting at the moment the ones that are all marked off with an X. So AC, drew a segment. AD, drew a segment. AE, drew a segment, right? So we took care of that first row. Let's go to the second row, B. BD and BE, right? So we have D and E for B. So B, we're going to draw one to D, and then B, we're going to draw one to E, right? So again, all we did was we connected B and D, and we connected B and E. So now if you look at it, it shows BA and then BC, no lines. BA, no line, BC, no line, right? Go to the next one, C. C is just telling us A, right? So we're going to connect C to A, which we have already. D is telling us A and B, right? So B, we're going to draw lines to A and B. D, we're going to draw lines to A and B. We have that already. And then E, we're going to draw lines to A and B. E, we're going to connect A and B. E, A, B. Great, we're done. And the reason I did that again, it's just to make sure that everything is connected, right? So first thing we did, we created a graph. All the red X's, it doesn't mean in the visual that that's what we're going to group together. What this tells us is just showing us how we proceed to it, right? So A, we had 3 segments, C, D, E, and then B, we had 2 segments. B, we had D, B, we had E, right? So everything is marked off because now from there, this is where the coloring part comes up, right? What we're going to do with the coloring now is we're actually going to fill this in. And I would say pick a point, right? Because once you have this, the table doesn't even matter anymore. Pick a color, any color. I'm going to go with blue, right? That's the first color I'm picking. So we have blue. Now, what we want to do, we want to see all the ones that can be colored blue. The only way you can color it the same color is if it's not connected, right? So if it's connected, it can't be the same color. If it's not connected, it could be the same color. So like for example, let's look at A, right? A is blue. Since it's connected to C, C can't be blue because they can't go together. Can't be the same color, right? So A and C are connected, can't be blue. A and D connected, can't be blue. A and E connected, can't be blue. A and B, they're not connected, so we can make this blue. So basically, the only ones that we want to color the same color are the ones that are not connected, right? The ones that aren't connected. So again, A and C, since they were connected, we can't make it the same. A and D, they're connected, we can't make it the same. A and E, they're connected, can't make it the same. A and B, they're not the same, they're not connected, they can be the same color, right? So now, since we went over all the ones that are blue, now we pick a different color. And again, it doesn't matter what point, right? Let's pick C. And again, our goal is to try to see what's the least number of colors we can use, right? So now again, and it's just good to look through it. we see that C and A, they're different colors. Now, let's see. C and D, they're not connected, so this can be green, right? Let's look at this. C and E, they're not connected either. They can be green. And that's it. And we know we're done because we've already gone through every color, right? We filled in every single vertex that we could have possibly colored in, right? We have all our colors. And now, if we just look at it, it's going to make sense because this segment, again, they're connected, different colors. Those two connected, different colors. Those two connected, different colors. These two connected, different colors. Those two connected, different colors. And us seeing that, these two, not connected, same color. These two, not connected, same color. These two not connected, same color. And so looking at this, we know that the least number of containers we would need to contain all these would be 2. We would need 2 containers, right? And the reason that we need 2 containers, and we know this, is because 2 different colors. We have blue, we have green, 2 colors, 2 containers, which means in order to contain all of these where some can't go together, we would need 2 containers to put them together, right? If we had 7 different colors, we would need 7 containers. But it's just that, guys. Resolving conflict, being able to use different colors to see. Always remember the ones with the red X, the ones that can't be together, those are the ones that we do draw first, because from that, we can then see which ones to not color the same way. That's how you resolve conflicts. And it's also a convenient way to put people in cars that don't get along. Because if Amy, Barbara, Claudia, Diane, and Elizabeth, you have 5 girls, we know that Amy and Elizabeth can't be in the same car because they're different colors. We know that Barbara and Diane can't be in the same car, different colors. We know that Barbara can't be with Claudia because, again, different colors, guys. Just that, right? So the way we would group these together would be exactly that. We would actually put Amy and Barbara in the same car. We would put Claudia, Diane, and Elizabeth in the same car. Hope this helped, guys. Take care.